November 7, 1943. Carpic Airfield, KH, France. The strong winds over the English Channel had used up fuel very fast. Second Lieutenant William E. Roach of the 358 Fighter Squadron, 355 Fighter Group watched. His fuel gauges dropped close to empty as his Pratt and Whitney R2800 engine started to cough. He had to make a hard choice. Ahead was England safe, but too far with the fuel he had below were French fields, some friendly, but most held by German soldiers. One airfield looked a lot like the Allied bases. He knew Roach decided to land there. The Big Republic P-47, D Thunderbolt No. 4, 222490, called Beetle, landed smoothly on the grass. Roach followed. A ground truck to park turned off his engine and then saw the black cross on the plains around him. The Germans he had fought just minutes ago now stood with rifles pointed at him. Lieutenant Roach's time as a combat pilot was over. He would spend the rest of the war at Stalag Luft 1, but now the Germans were going to learn something they never expected when they checked Beetle. They found things that changed what they thought about American power and technology. The P-47 Thunderbolt was not just a fighter. It showed what American engineers could do and how strong their factories were. For the next 18 months, German engineers took the Thunderbolt apart, tested it, and flew it. They soon saw a hard truth. Germany had not just fallen behind in technology. They were fighting a totally different kind of industrial war. The story of the captured P-47s in German hands reveals how having huge material power, when used right in air battles, could make skill and smart. Flying not enough to change how the war would end, the Thunderbolt would give German engineers lessons they badly needed but could never use. Their country did not have the supplies, the strong factories, or the time to build what American plants made every day. When William Roach's P-47 was taken on November 7, 1943, it was not the first time the Luftwaffe had seen. The Thunderbolt German pilots had fought the big American plane since April 1943, when the 4th Fighter Group first flew beside B-17 bombers into enemy air over Europe. At first, German reports showed both dislike and confusion. German flyers used to the fast Fokker Wolf Fu-190 and Messerschmitt Bf 109 thought the American fighter was huge, slow near the ground, and made by people who knew nothing about real air battles, the way the Luftwaffe saw them fight notes from German units through the spring and summer of 1943 kept saying the P-47 climbed badly handled slow at low heights, and that American pilots seemed scared to join close-turning dogfights. At first, the skilled Luftwaffe pilots believed the Thunderbolt was a weaker design that German pilots could easily outfly at medium heights. Where most fights happened, this idea would soon prove very wrong, but those same reports also showed clues that told a different story. Pilots said Thunderbolts that pulled away from fights could never be caught once they went into a dive. They talked about 8 big machine guns that hit hard when the American pilots chose to fight. They noticed armor so strong that normal 7.92mm bullets could not get through, and even 20mm shells sometimes failed. The most shocking thing they saw was that Thunderbolts badly hit in battle still kept flying. Many made it back to England, even with holes in their wings. Engines leaking oil and parts shot off, yet still under full control. When Lieutenant Roach's Thunderbolt stopped safely at Carpic, the Luftwaffe at last got a close look at the plane. They had been judging wrong German crews right away. Knew this was a big find. A whole undamaged American fighter, within hours. Beetle was ringed by armed guards to stop anyone from wrecking it. The American signs were quickly covered with German black cross marks on the wings and body, and bright yellow paint was put on the bottom and tail. This yellow color, called Rechlin 04, was always used by the Luftwaffe on captured planes, so German guns would not shoot them by mistake soon after the capture orders came to move the plane to Rechlin, the Luftwaffe's top test base, about 100 kilometers northwest of Berlin, inside Mecklenburg was given the code T9 plus FK, the marking used by the Circus Rosarius test unit. Hans Werner Lerche, the main test pilot and chief engineer at Air Proving Center Rechlin, was chosen to fly the first test flights. Lerche, who would end up flying over 125 kinds of planes in the war without ever crashing or badly breaking. One looked at the P-47 with interest, but also careful respect, because its systems were new to him. His first thoughts, written in his flight notes and later in his book Luftwaffe Test Pilot Flying Captured Allied Aircraft of World War II, showed surprise at how complex the cockpit was. The dashboard had almost twice as many gauges as German planes. There were strange levers for systems he had never seen. The turbosupercharger needed knowledge of exhaust flow control ideas that German engineers only talked about in theory. But Americans already used the constant speed propeller, worked in a different way from German ones. The hardest part was the automatic engine control that replaced the German habit of changing throttle and fuel mix. By hand, Lerche wrote that the P-47 cockpit could confuse even an expert pilot. He slowly learned what most levers and dials did, but some were still a mystery. He spent a lot of time on the ground testing controls and studying before flying, showing his careful way of testing planes without any pilot books or guides. Even starting the engine showed how advanced it was. The Pratt and Whitney R28, 00 Wasp, needed exact steps to get the huge turbo system running. Right, Lerche followed each one closely. Thinking through what every step did when the 18-cylinder engine started, it made a deep, strong growl, not like the sharp sound of German straight engines or the BMW 8.1, radial of the FW190. It was a low, heavy rumble that showed how big and powerful it was. Lerche rolled forward, slowly feeling the heavy plane through. The stick, the P-47D, weighed almost 10,000 pounds empty, and this one still had lots of fuel and full ammo, making it close to 13,500 by comparison. The FW190A81 of Germany's biggest single. Seat fighters weighed about 7,650 pounds empty and around 10,800 pounds. When fully loaded, the Thunderbolt was truly huge for one seat. It was even bigger than some German twin-engine planes. Lerche pushed the throttle forward to take off, and right away the difference between German and American design showed. The R2800 engine made 2,000 horsepower at normal boost and up to 2,300 with water methanol injection. The German BMW 801D, the best radial engine Germany built, and the one used in the FW190, made about 1,700 to 1,730 horsepower. Even with more power, the P-47 was so heavy it needed almost the whole grass runway to lift off. But once in the air, Lerche began to see why German pilots who only fought Thunderbolts low down had missed what the plane could really do. He climbed higher, carefully warming up. The turbosupercharger as he went under 15,000 feet. The P-47 felt just as German flyers had said, heavy, slow to turn, and not as quick as German planes. Its climb speed was just fair compared to the FW190 or BF-10. At these lower heights, any good German pilot in a modern fighter could turn and outfly a Thunderbolt. But above 20,000 feet, the plane started to change completely. The turbosupercharger powered by used the exhaust flow and grew more powerful as the air thinned with height. It started pushing huge amounts of air into the engine, while German engines struggled to breathe and lost strength. The R2800 kept its full power at 25,000 feet, where German fighters could only use about 70% of their normal force. The Thunderbolt still gave everything. Lerche moved the throttle ahead, and felt the big plane speed up fast for its size. He rolled it into a dive to test how it handled at high speed. The plane dove past 500 miles per hour. The controls got very stiff as air pushed hard on the wings and body pulling up. Needed both hands and strong effort. The plane was reaching air speeds near the limit of what could be handled before the jet age. The roll rate surprised Lerche right away and proved German pilots had been wrong about the Thunderbolt being slow to turn. Even though it was large and heavy, it could roll quicker than any German plane Lerche had flown. Even the FW-190, which was known for fast rolls. This, together with its dive speed, gave American pilots a big edge. German reports had mentioned it, but few understood what it meant. If an American pilot was in danger high up, he could flip the plane over and dive away so fast, no German fighter could follow. Any German who tried would face control, lock problems from air pressure. That the P-47's strong body and controls could handle easily, Lerche tested the captured plane fully using regular Rechlin test steps. His early notes worried Luftwaffe leaders who still thought their planes were the best at heights above 25,000 feet, where more battles were happening as bombers flew higher to dodge German guns. The P-47 Thunderbolt was not weaker than German fighters. It was stronger in key and vital ways that removed any German edge in turning ability or climbing speed. In the next few weeks, the Rechlin engineers put Beetle through long and careful tests using regular air-proving ground methods. They took photos of every part from many angles. They measured each piece exactly with fine tools. They weighed all major sections and checked how every system worked under different settings. They gave extra study to the turbosupercharger, because that was the main thing that made American high-altitude planes different from German ones. What they found when they looked closely amazed the engineers who were used to working with limited materials. The Pratt and Whitney R2800 double Wasp had 18 cylinders in 2 circles of 9 around a middle crankshaft. The total size was 2,845 cubic inches, or about 45.958 liters. The German BMW 801D, by comparison, had 2,560 cubic inches, or 41.88 liters. But the bigger size was not the only reason for the extra power the American engine used. Strong aluminum pistons, exhaust valves cooled with sodium to handle high heat, and a crankshaft made from top-quality steel that German metal experts admired. Knowing they no longer had enough of such metals, the level of American materials and factory skill amazed the German examiners. Every part looked perfectly made with exact fits. The surface of each piece was smooth and finely finished. The magnetos were built with materials that were becoming hard to find in Germany. Rare in Germany, the spark plugs used top-quality ceramics that were much better than German ones. The fuel system worked with the kind of exactness German engineers thought belonged in labs, not in warplanes expected to fly in rough battle. The most striking thing was that the whole engine showed no sign of cheap materials or quick fixes forced by lack of supplies. The Americans had built it exactly the way it was meant to be, with every proper part and no cut corners. The turbosupercharger showed a level of design skill that Germany had tried but never managed to use in real planes. The exhaust gas from all 18 cylinders went through pipes along each side of the plane to a turbine placed behind and under the cockpit. The turbine spun very fast, using the hot exhaust to drive a compressor that pushed extra air into the engine. The setup had an intercooler that cooled the air so it became denser and stopped. Engine knocking automatic controls kept the boost power and turbine speed steady, without the pilot needing to adjust anything other than the main pressure setting. German engineers knew the theory well and had tested similar systems, but they could not make one work in factory-built warplanes because, by 1943, their materials and production lines were too limited. needed special high-heat metals for the turbine blades that had to survive extreme heat while spinning at very high speed. The control system needed exact factory work and strong, reliable parts. The long air pipes required heat-proof material and tight seals to work right. All of it had to keep running in battle through shaking, freezing cold near minus 60 degrees at height and over 200 degrees close to the engine, plus any damage from fighting. The Americans had solved every one of these problems and put the full system on every P-47. Made the turbosupercharger was not a test item, or built only for a few planes. It was part of all Thunderbolts built by the thousands. This normal use of such advanced design showed a factory power that German engineers could barely believe. German reports from the Rechlin tests said the turbo-supercharger alone proved a level of skill and factory strength beyond what Germany could copy or build in large numbers. The metals, the careful building, and the checking needed to make such systems in bulk were more than German industry could manage. In 1943, with shortages and factory quality dropping because of Allied bombing and loss of trained workers replaced by forced labor, the weapon system gave another clear sign of American plenty and careful design. The P-47D carried 8 Browning M2 machine guns of 50 caliber with 4 in each wing. Most German planes of that time carried a mix of weapons, usually 4 machine guns and 2 20mm cannons, or early versions had 6 guns total. The Americans chose to fit 8 heavy guns to make the firepower as strong as possible, even though it added more weight and made things more complex. Each gun got its own ammo box built into the wing, each holding 425 bullets. The total ammo was 3,400 rounds for all 8 guns. For comparison, the FW-190A usually carried around 2,000 bullets for its guns and 500 shells for its cannons. A P-47 pilot could shoot all 8 guns for about 20 seconds before running out, with all 8 firing together at about 100 bullets every second, when all guns were aimed to meet at one spot in the air. The amount of fire was massive for any target German test. Shots with the captured plane showed how deadly it was. The way everything was built also amazed German weapon experts. Every gun sat in a heated space to stop freezing at high altitudes where the cold could drop to minus 60 degrees. Spent shells and broken belt parts dropped down chutes and outholes on the bottom of the wings, so nothing hit or jammed the plane. The setup worked perfectly during Rechlin tests, even after shooting thousands of rounds in different air conditions with no jams or feed problems at all. Ammunition quality showed another side of America's strong industry. The 50 caliber bullets had armor-piercing cores made to steady standards, incendiary parts that always worked, and tracers that burned evenly. Tests showed that American ammo was more dependable than German ammo, which had lost quality as key materials grew scarce. The Thunderbolt's armor showed that Americans were willing to carry extra weight to keep the pilot safe, a big difference. From German design ideas, the cockpit was covered with thick armor plates on many sides. The pilot sat inside what designers called an armored bathtub, giving strong protection from below and behind. The front glass was bulletproof, thick enough to stop machine gun shots and resist cannon fragments. More armor plates guarded important parts, like the oil coolers and the turbo-supercharger that could be easily damaged. Altogether, the armor weighed over 200 pounds, about the same as adding 2 more machine guns with ammo. German fighters usually had less armor because they wanted lighter planes and faster performance, even if it meant more pilot deaths in battle. This showed how differently each side thought about warplane design. The difference showed clearly in how easy the planes were to fix. American designers knew that mechanics on front bases might have to repair planes fast, maybe at night in bad weather, or under attack. Every big part could be reached through large, panels held by quick-release locks needing only simple tools. The big engine could be swapped in just a few hours using normal hoists and clear instructions. German fighters built for factory-level repairs needed more parts taken off to fix major pieces. This showed America's wealth compared to Germany's shortage. Americans could spend time making planes easier to fix because their strong industry let them plan for smooth operation, not just fast building. The captured P-47's radio setup also showed how advanced American tech was. The plane had an SCR-2174N radio for talking air-to-air and air-to-ground, plus an SCR-515A radio for more channels. Both worked with clearer sound and longer range than German radios, which often had noise problems. Americans had fixed these with better parts and shielding. The radios also linked with a friend or foe system that told ground crews which planes were friendly, stopping friendly fire mistakes. This kind of smart system was something Germany did not have in 1943. The biggest surprise for German engineers didn't come from one special part, but from the whole plane's amazing quality. Every single piece looked like the best version that American engineers could make. Nothing seemed cheap or replaced because of missing materials. Nothing looked rushed or changed like the German planes that had to use whatever parts were left as bombs hit their factories and supplies ran low. Reports written at Rechlin and shared through the Luftwaffe's technical offices said this again and again. The P-47 Thunderbolt was built exactly how its makers had planned, using all the right materials and steps with no cuts or swaps because of shortages. This kind of perfect building had become almost impossible for German factories as the war dragged on. Flight tests went on through the winter of 1943 into early 1944, when more P-47s were captured and brought to Rechlin for comparison. Then, on May 29, 1944, another P-47 fell into German hands when Second Lieutenant Lloyd S. Hathcock from the 3001st Fighter Squadron, 332nd Fighter Group got lost during a ferry flight and accidentally landed at the Rome Littorio airfield in Italy, which was under German control. The Germans quickly took his plane, serial number 42-75971. This P-47 had once been flown by George Noatney, a skilled ace with 8 victories from the 317th Fighter Squadron. The Germans moved the plane to Rechlin, where it was first marked 8+6, then later sent to Circus Rosarius on October 12, 1944, and renamed T9+LK. The test results gathered at Rechlin led to new flying tips that were shared with frontline Luftwaffe fighter units. These reports told German pilots that their best chance to beat a P-47 was to fight below 15,000 feet, where the Thunderbolt's slower climb and weaker low-altitude speed made it easier to handle. They were also told not to dive away from a P-47, since the American plane could dive much faster than any German fighter. The reports warned that damaged Thunderbolts often kept flying, even after taking heavy hits, so pilots had to attack hard and keep shooting until the P-47 was truly destroyed. Still, these flying tips could not solve the bigger problem. Germany was fighting an enemy with far greater resources. Every P-47 that was lost was replaced within days, with factories making over 300 planes a month at their highest output. American training schools produced more skilled pilots than Germany could, since German training was cut short and fuel was scarce. The U.S. supply system kept the Thunderbolts fully stocked with fuel, ammo, and spare parts, while German supply lines were breaking under endless Allied bombing. In the end, the captured P-47s were sent to the Circus Rosarius. The special Luftwaffe show unit was led by Flight Captain Theodore Rosarius. This team traveled to German air bases across occupied Europe, where they showed captured Allied planes so German pilots could study them up close. These shows had two main goals: to teach and to motivate. Pilots learned how to recognize enemy planes and understand how they behaved in combat. But they also saw proof that many Allied aircraft were better in key ways, especially at the high altitudes where more battles were being fought. After the war, Luftwaffe pilots who had watched these shows said they were deeply affected by seeing American fighters perform so well. Even though the Zircus Rosarius pilots could demonstrate that German planes were still strong at certain heights, mainly at medium altitudes, the shows made it clear that at the higher levels where American bombers and their P-47 and later P-51 escorts flew, German fighters were at a serious disadvantage. The information collected from captured Thunderbolts gave exact performance numbers that went against earlier, overly hopeful German reports. At sea level, the P-47D could reach about 350 miles per hour, which wasn't very fast compared to the FW-190A's 408 miles per hour at the same height. But at 10,000 feet, the Thunderbolt could already hit around 375 miles per hour. But at 30,000 feet, the P-47 could reach 426 miles per hour, while the Focke-Wulf struggled to hit 370, and the Bf-109G managed only about 385. The P-47's power at high altitudes was clear and decisive, and it mattered more and more as Allied bombers flew higher to avoid German anti-aircraft guns. The difference in service ceiling was also discouraging for German pilots. The Thunderbolt could reach 42,000 feet, while German fighters rarely worked well above 35,000. Their engines lost power fast in the thin air. American bombers often flew at heights where German planes could barely reach them, and when they did, they had too little power left to fight effectively. The P-47 escorts, on the other hand, could stay high and still fight at full strength. When it came to flight range, America again had the upper hand. With extra fuel tanks, the P-47D could fly deep into Germany alongside bombers. Early Thunderbolts had limited range, but by 1944, those fitted with 108-gallon drop tanks could fly over 1,000 miles per mission. German fighters, built mainly for short-range defense, could not match that reach. German short-range fighters defending the Reich did not have enough internal fuel for long missions. This meant American planes could choose when and where to fight, while German pilots had to stay on the defensive. The captured Thunderbolts also showed how well American pilots were trained and what tactics they used by studying gun camera films and damage on planes that survived combat. The evidence showed American pilots always used the P-47's strengths and avoided its weaknesses. They stayed high where the turbosupercharger gave them an edge. They attacked with dive and zoom maneuvers instead of turning fights where German planes were stronger. They flew in pairs or 4 plane groups supporting each other, even if it meant giving up a chance for personal glory. This careful teamwork impressed Luftwaffe analysts. Many German aces preferred to fight alone, relying on skill and aggression. But American pilots followed rules consistently, helping each other, and rarely letting pride get in the way. This disciplined approach, combined with better high-altitude planes and growing numbers, made it harder for even the best German pilots to win. By D-Day in June 1944, the overall situation had become so bad that intelligence from captured planes gave Germany almost no practical help in the war. The Luftwaffe knew American planes were better in key ways. They understood American flying, tactics, and had detailed technical information on Allied aircraft performance. But having this knowledge did not give them the resources, materials, factories, or trained pilots to compete. The Rechlin reports, carefully prepared and shared throughout. Luftwaffe technical services mainly showed the technological and industrial gap pushing Germany toward defeat. The difference in engine production made Germany's problem clear. Pratt and Whitney, together with Ford, produced over 125,000 Untold or 2800 engines by the end of the war. This one engine type outnumbered all combat aircraft engines. Germany made BMW built about 61,801 radial engines in the entire war, and Daimler-Benz made roughly 42,400 DB605 inline engines. American output of a single advanced engine was more than Germany produced of all combat aircraft engines combined. In 1944, American factories made about 96,000 planes, while Germany managed about 25,000 of all types. The U.S. alone built 38,000 fighters, 16,000 heavy bombers plus thousands of medium bombers, transports, and trainers. Together with British and Soviet production, the Allied advantage in planes was more than 5-to-1 by. In 1944, the industrial scale behind American production was far beyond what Germany could match. The Aluminum Company of America alone made more aluminum than all of Germany's aluminum industry. American steel mills often outproduced the entire Ruhr industrial region. Car factories used moving assembly lines, while German plants worked in batches. Even the machines that made aircraft were produced in such numbers that American factories could meet their own needs and still supply Britain and the Soviet Union. The captured P-47s ended up being collected during the final chaotic months of the European War. The plane, called T-9 plus FK, originally William Roach's Beetle, was recovered by American forces at Göttingen in May 1945. Found among other captured Allied aircraft, the Germans had been testing. Photos show the plane still with partial German markings parked next to FW-190s and BF-109s in what looked like a museum of captured planes, showing how much intelligence work the Luftwaffe had done. The Thunderbolts used by German evaluation units taught German pilots and engineers lessons they badly needed, but it was too late to change the war. The aircraft showed that American industry valued full capability over elegance, plentiful resources over careful efficiency, and systematic material advantage over individual technical skill. These priorities. When American industry combined nearly unlimited resources and massive factories, it made weapons that outperformed German planes overall, even if German designs were better in some specific areas. This lesson went far beyond the P-47. Every type of captured American equipment told the same story. The B-17 Flying Fortress, with its 4 turbo-supercharged Wright Cyclone engines, gave America a strategic bombing power Germany never matched. The P-51 Mustang paired American airframe design with the British Rolls Royce Merlin engine, creating what many historians call the best piston engine fighter of the war. The P-38 Lightning, with 2 turbocharged engines and tricycle landing gear, showed Americans were willing to try unconventional ideas. Every plane showed the same principle: solve problems with strong engineering backed by huge industrial power. Instead of clever fixes, limited by shortages, Luftwaffe analysts saw clearly they were not losing because of better tactics or more skilled pilots. Although American training did produce enough good pilots in large numbers, they were losing because American industry could design capable equipment and then build it in such quantities that German advantages became meaningless. The Americans designed around their industrial strengths using massive factories, plenty of raw materials, and efficient supply systems. By 1943, Germany was trying to use clever engineering to make up for its weak industry they were attempting to achieve through design, what they could no longer do through manufacturing. The strategic effects were well known in Luftwaffe technical offices. By the end of 1943, Germany had one of the world's most advanced air forces, with planes often better than their opponents. On a 1-to-1 basis, German pilots were initially better trained and tactics were more advanced, but German industry could not keep these advantages against enemies with far greater production power. American plane production doubled repeatedly. In 1940 again, in 1941, again in 1942, and kept growing until, by 1944, American factories made over 96 planes a year, while Germany never exceeded 40,000 in any year, despite desperate efforts. The quality gap between American and German planes kept growing. In 1942, German planes were often better than American planes. By 1944, American planes matched or beat German designs in nearly every key area. By 1945, the difference became enormous. American fighters, like the P-51H and P-47N, were improved versions of already excellent designs. German fighters, like the T-152, were desperate attempts to get more performance from industrial systems collapsing under Allied bombing shortages of raw materials and replacement of skilled workers with poorly trained forced labor. The effect on Luftwaffe morale facing endless streams of good enemy planes was as damaging as the material losses. German pilots said they felt less like warriors in honorable fights and more like targets in a relentless destruction campaign. No matter how many Allied planes they shot down, more came the next day. No matter how well they fought, American numbers eventually won through sheer attrition. Knowing that their enemies' planes were often better than their own, made in much greater numbers supported by superior logistics and flown by adequately trained pilots, who were quickly replaced, created a strong feeling of inevitable defeat that spread through the fighter forces in 1944. The captured P-47s were clear physical proof of this. These were not propaganda or exaggerated reports. They were real planes that German pilots could inspect. The Thunderbolt was not a miracle or revolutionary. It was simply a very good fighter properly designed for its mission, with enough power, well-armed, properly protected, and built in numbers large enough to overwhelm the enemy through steady application of material advantage. The final historical irony was that Germany learned these lessons, fully documented them carefully, and understood their meaning but could never use the knowledge. Understanding American. Industrial power did not give Germany the aluminum, steel, fuel-skilled workers, intact factories, or working transport needed to make the same planes in the same numbers. Knowing the P-47's capabilities did not provide the high-temperature alloys, precision machinery, quality control, or trained workforce required to build comparable turbosupercharger systems. Intelligence from captured aircraft showed the scale of German defeat with professional thoroughness, without offering any realistic way to avoid it. When Allied forces captured Rechlin and its related facilities in May 1945, they found extensive records of the captured aircraft program. German technical reports filled filing cabinets, detailing every measurable feature of every American and British plane examined during the war was recorded in the reports. The reports showed technical thoroughness and scientific objectivity. They represented thousands of hours spent documenting capabilities Germany could observe and measure, but never copy. Given their worsening industrial situation, American intelligence teams reviewing the German reports after the war noted with interest that German engineers understood American aircraft capabilities more clearly and in more detail than American commanders sometimes did. The Germans identified weaknesses in American designs that pilots learned to work around. The technical analysis was often more detailed and rigorous than American evaluations of their own planes. German engineering skill was never in question. But American reviewers also saw what the German reports revealed about Germany's strategic position. Germany tried to fight a modern industrial war with an industry that could not meet the demand. They compensated with excellent engineering, well-trained pilots in the early war years, and innovative tactics. These strengths gave early victories against opponents with similar resources. But against the United States, with industrial power, surpassing all other major powers combined good. Engineering and skill could only delay defeat, not prevent it. The story of German engineers examining captured P-47 Thunderbolts is a clear example of industrial warfare in Huawei. The Thunderbolt succeeded, not because it was the best fighter by every measure, but because it was very effective and built in numbers that made technical superiority of individual planes irrelevant. American industry produced 15,683 Thunderbolts, while also building 15,486 P-51 Mustangs, 10,037 P-38 Lightnings, 13,738 F-6F Hellcats, and 12,571 total American fighter production exceeded 70,000 planes during the war, and each plane represented thousands of hours of skilled work, tons of aluminum and steel, hundreds of precision parts, and manufacturing capacity Germany could not match. The P-47 Thunderbolt became a symbol of American industrial power to German pilots who faced it. Luftwaffe pilots used the same nickname, American. Pilots had given it, calling it the Jug because of its awkward appearance. They also called it Indiana after the Thunderbird emblem. Many squadrons painted on engine cowlings. As losses grew and the strategic situation worsened, some called it simply the 8-gun fighter and learned the hard way to avoid fighting. Thunderbolts at altitudes where the American plane had tactical advantage, which increasingly meant staying below. 20,000 FT where the turbosupercharger gave the P-47 decisive performance. By the end of the war, P-47 Thunderbolts had destroyed about 3,752 enemy planes, while about 3,499 P-47s were lost to all causes, including accidents, mechanical failures, and ground attacks. This roughly 1-to-1 loss rate seems unremarkable until you consider that Thunderbolts mainly served in ground attack from mid-1944 facing heavy anti-aircraft fire at low altitudes instead of mainly fighting in the air in the pure fighter escort role during 1943 and early 1944. P-47s had much better exchange rates, especially at high altitudes where the turbosupercharger gave a big advantage. The ground attack role showed another part of American design philosophy, emphasizing versatility. When P-51 Mustangs with longer range began taking over bomber escort duties in 1944, the 9th Air Force reassigned many Thunderbolt groups to tactical air support. The tough P-47 with its reliable air-cooled radial engine and heavy armor was ideal for dangerous low-altitude attacks, the same traits that made it feel slow in low-altitude dogfights. Large size, heavy weight, strong armor, and powerful guns made it nearly perfect for ground attack where survival and firepower mattered more than maneuverability. Thunderbolt pilots on ground attack missions destroyed huge amounts of German military gear. Official reports using gun camera footage and after-action reports documented over 86,000 railway cars, 9,000 locomotives, 6,000 armored vehicles, and 68,000 trucks destroyed or damaged. Some duplication probably occurred, but the scale of destruction was clear and had real effects on German operations. The P-47, carrying bombs and rockets, in addition to its 8 machine guns, became a true multi-role combat plane. German ground troops learned to recognize and fear the deep rumble of the Pratt and Whitney R-2800 radial engines at low altitude. That sound warned of attacks they could do little to stop. The constant air attacks, combined with big material losses and disrupted logistics and communications, lowered German ground forces' combat effectiveness in 1944 and 1945. As for the captured aircraft, William Roach's P-47D Beetle 42-22490, called T-9 plus FK by the Germans, survived the war and was recovered by American forces at Göttingen in May 1945. After American intelligence studied it, the plane was eventually scrapped. Lloyd Hathcock's P-47D 42-75971 T-9 plus LK, had a similar fate. Recovered, but not preserved. The pilots' fates differed. Roach spent the rest of the war at Stalag Luftwaffe in Barth, Germany. He was freed by Soviet forces in May 1945 and returned to the U.S. Hathcock, spent 11 months as a POW, mostly at Stalag Luftwaffe, the site of the Great Escape 3 months before he arrived. He was the only African-American pilot among thousands of white prisoners. In January 1945, Soviets advanced, and Germans evacuated the camp, forcing prisoners on a brutal winter march to Stalag 7A and then Stalag 13D. Hathcock was freed by Allied forces in April 1945. He returned to the U.S., helped desegregate the Air Force, and later worked on aerial reconnaissance photography innovations at Wright-Patterson Air Force Base. Hans Werner Lerche survived the war despite flying 125 aircraft types, including many captured Allied planes. He never crashed or seriously damaged a plane during his test pilot career, a unique record. After the war, he gave detailed debriefings to Allied intelligence about German aircraft programs. His memoirs, published in 1977 in German and translated into English in 1980, provide one of the most detailed, first-hand accounts of the German captured aircraft evaluation program and insights into how the Luftwaffe studied Allied technology. The bigger lesson from captured P-47s goes beyond technical details. The evaluations at Rechlin showed that by 1943, the air war in Europe was being decided not by pilot skill, tactics, or aircraft specs alone, but by industrial capacity on a national scale. A nation that could design decent equipment and produce it in huge numbers, while also supplying everything else a modern military needed, would beat opponents producing technically superior equipment in smaller amounts. By late 1943, Germany faced an enemy whose combined industrial power was at least 5 times greater. When Britain refused to surrender after France fell, the Soviet Union survived and moved its industry out of reach, and the U.S. entered the war with its massive, untouched industrial base. Germany's path to victory was essentially blocked. The story of Beetle and other captured Thunderbolts at Rechlin shows Germany's broader strategic problem. German engineers could study American equipment, understand it, capabilities, and accurately measure American industrial strength. This knowledge was carefully collected, analyzed, and recorded. But knowing alone could not create the aluminum, steel, rubber, fuel, machine tools, skilled workers, intact factories, and functioning railroads needed to match American production. The Republic P-47 Thunderbolt, studied in detail by German engineers at Rechlin, proved a fundamental truth about modern warfare. Material abundance, applied through solid engineering and competent tactics, could defeat technical excellence limited by scarce resources. America's greatest weapon was not a single technology, no matter how advanced, but its entire industrial system, able to design, test, produce, and supply thousands of complex weapons at once while keeping quality high and improving designs based on combat experience. The captured Thunderbolts showed this clearly. German engineers measured, documented, and reported it professionally. But the lesson came too late. By the time William Roach's Beetle was examined at Rechlin in late 1943, the war's outcome was already set by industrial math that no amount of German skill or bravery could change. The Thunderbolts on German airfields, hastily marked with Balkenkreuz over American stars, symbolized a future that had already arrived, one where industrial capacity had become the deciding factor in modern warfare.